All right, today we're looking at solving an equation using a graph. So what are we looking at? We're looking at giving an equation, so we have an expression on one side of the equal sign, another expression on the other side, and we're going to use a graph to solve that equation. So we're going to solve by the equation by finding the intersection of the two graphs. So the solution will be the x values of the intersection points. So how? First we'll graph both of the sides of the equation. So let's say we have 2x equals 3x plus 4. What we're going to do is we're going to set each expression on either side of the equal sign, we're going to set them equal to y. So we'll set y equals 2x and then y equals 3x plus 4. We'll graph both of these equations and then we'll find the intersection point. Now other intersection points, they may have 1, they may have 2, they may have 3. That intersection point is going to be the answer, or solution is going to be the x value of that intersection point. Now, what we're looking at tonight, we won't need to round it to the nearest hundredth, but when we're taking a look at problems tomorrow, we will need to round to the nearest hundredth. So the first problem we have is find the solutions of x squared plus 1 equals x plus 3. Now, these are already graphed for us. So first, we would graph y equals x squared plus 1, and then graph y equals x plus 3. And our solutions, here we're going to have 2. Since we have 2 intersection points, our solutions are the x value of that ordered pair. So the blue line is y equals x plus 3 graphed, and the red line is y equals x squared plus 1 graphed. So that ordered pair, the first intersection point, is negative 1, 2, and then we have the ordered pair 2, 5. So our solution is going to be the x values. So our solutions, we have 2 of them for this equation, is negative 1 and 2. Now, of course, especially some of these you can solve algebraically, but we want to take a look at solving it graphically. So you can always check your solutions by substituting negative 1 in for x and then 2 in for x to make sure you get the same expression. So we're just going to check this one. So we have negative 1 squared plus 1 equals negative 1 plus 3. Negative 1 times negative 1 is positive 1 plus 1. Negative 1 plus 3 is 2. 2 equals 2. So negative 1 is the solution. And let's check 2. So we have 2 squared plus 1 equals 2 plus 3. So we get 4 plus 1 equals 5, which is true. So that's our solution. So that's how you can check them algebraically once you get your solutions. All right. Problem 2. Here we have some waves. Now I don't have the specific equations for these, but the property is the same. So our solution is going to be the x value of each point of intersection. So we're going to assume this is a scale 1, 2, 3, so counted by ones. So we have 4 intersection points. We have 4 points where these two functions intersect, where they overlap. So this first ordered pair is about negative 2.5. Second ordered pair is about negative 1.5. This ordered pair here is about 1/2.5, and our last ordered pair appears to be about 2.5 and then 1/2. So once again, when we're finding the solutions, we just take a look at the x values of our ordered pairs. So our solutions here are negative 2, negative 1, 1/2, and 2.5. Now when you're expressing your solutions, you want to put an order from least to greatest, so your smallest number to your largest number. All right, our next equation we have is x plus 1 equals 2x. So once again, we set each side of the equal sign equal to y, so y equals x plus 1, and then y equals 2x. And our solution is going to be the x value, once again, of where they intersect. So here we have one solution, we have one point of intersection, so our solution is 1. The fourth one, we have y equals x squared minus 4x minus 5. That's our parabola. And then we set y equals 0. Now when y equals a number, we're taking a look at a horizontal line at that y value. So y equals 0 is our y-axis, or x-axis here, because at every point on the x-axis, the y value is 0. So our solutions here are where our parabola crosses the x-axis. So here we have 2 solutions, and our solutions are negative 1 and 5. All right, one last problem. Once again, these are both already graphed for us. So we have y equals negative 1/2 x plus 6 and y equals negative 1/2 x plus 1. So when we graph these two solutions, we can sort of look at it as graphing a pair of linear systems. We notice we have parallel lines. Now we could look at that automatically and say, same slope, parallel lines, they're never going to intersect. So since these lines never intersect, we have no solution. So it's the same type of process in a way as when we solved linear systems. So that will come into play as well. All right, hope you have a great evening, and I will see you tomorrow.